Welcome to the industrial backbone of Canada, where the rust tells a story of survival, and every rivet holds the weight of a nation's ambition. You stand on the edge of a frozen valley in the Yukon, the wind whipping needles of ice against your exposed skin. Before you sits a mountain of riveted steel, a 3,000-ton beast of burden that looks more like a battleship than a mining tool. The air is so thin and cold it tastes like iron, and the only sound is the rhythmic, haunting groan of shifting permafrost beneath the massive wooden hull. This is not a machine built for comfort. It is a predator designed to eat the very earth it sits upon. The scale is staggering, a 5-story cathedral of industry dropped into a wilderness that wants nothing more than to freeze it solid and forget it ever existed. Think your modern diesel truck is tough? Try keeping a 3,000-ton steam dredge alive in a 40-degree Yukon winter. Back then, preventative maintenance often meant crawling into a dark, grease-slicked gear housing with a flickering candle and a prayer. So, before we fire up the boilers, take a moment to like the video and subscribe, but only if you find this deep dive into our industrial history valuable. If your grandfather spent his life swinging a wrench on the Canadian Pacific Railway, or if you currently work in the trades or heavy engineering, share your story in the comments. We build the future on the foundations these veterans laid in the mud and the snow. Now, let's descend into the gears and grease of the machines that built the Great White North. You feel the vibration starting deep in the soles of your boots as the massive bucket line begins its slow, agonizing rotation. To understand this machine, you must understand the logistical insanity required to bring it here. In the early 1900s, the Canadian government faced a geographical crisis. The gold was there, but the gravel was frozen harder than concrete. In 1912, the cost to transport a single ton of freight from Vancouver to the Klondike often exceeded the value of the freight itself. To build this specific beast, engineers had to dismantle it into thousands of numbered parts, each small enough to fit on a riverboat or a horse-drawn sledge. Imagine the precision required to reassemble a 3-million-pound puzzle in a place where the nearest machine shop is 1,000 miles away. If you dropped a specialized bolt into the snow, you didn't just drive to the hardware store. You waited 6 months for the next supply trek. Precision engineering in 1912 meant hitting a stubborn steel pin with a 20-pound sledgehammer until it finally sang in the right key. You appreciate the irony of using such brute force to achieve a fit that modern lasers would struggle to replicate. The heart of the operation is the bucket ladder, a massive steel tongue protruding from the bow. Each of the 75 buckets weighs over 2 tons, cast from manganese steel to withstand the abrasive nightmare of frozen riverbed. You watch as the upper tumbler, a massive hexagonal drive sprocket, clunks over, dragging the chain upward. The sound is a deafening, rhythmic thump-shriek-thump that echoes off the valley walls. This isn't just digging. It is a mechanical assault on the geology of the Yukon. The engineering solution for the permafrost was as simple as it was brutal: steam points. Before you can even move the dredge, you have to drive hollow steel rods into the frozen earth, pumping high-pressure steam into the ground for weeks. You are essentially boiling the landscape just to make it soft enough for the steel buckets to bite. The sheer volume of wood required to fuel this process is staggering. In 1905, the Yukon Gold Company employed more woodcutters than miners, stripping entire mountainsides bare just to keep the boilers screaming. You see the stumps protruding from the snow, a silent testament to the energy required to conquer the frost. As you walk the narrow gangways, the smell of hot tallow and wet coal smoke fills your lungs. The deck beneath you is slippery with a mixture of spilled oil and melting frost, a treacherous environment where one slip means a fall into the freezing pond below. There are no safety railings here, only the cold reality of the job. The men working beside you have hands calloused like boot leather and eyes that never stop moving, watching the tension in the cables. Every cable is a lifeline. The spuds, massive steel pillars at the stern, are dropped into the mud to act as a pivot point. By winching the bow cables left and right, you make the entire 3,000-ton structure swing in a slow, majestic arc. It is a dance of immense weight and subtle tension. You realize that you aren't just operating a machine, you are maneuvering a floating factory. The hull, built from massive Douglas fir timbers shipped from the coast, must withstand the constant torque of the digging ladder while supporting the vibrating weight of the processing plant above. The engineering of the time relied on mass and momentum. There were no hydraulic sensors to tell you if the bucket line was snagged on a boulder. Instead, you listen to the pitch of the steam engine. When the bark of the exhaust deepens into a low, strained growl, you know the buckets have hit something they can't chew. You reach for the massive cast iron friction levers, your muscles straining against the weight of the mechanism. There is a tactile honesty to this work. You feel the machine's struggle in your own shoulders, a direct connection between man and metal that modern digital interfaces have long since severed. The grit of the men who built this cannot be overstated. They worked in 12-hour shifts, surrounded by the constant roar of the machinery and the spray of icy water. If a bearing seized in the middle of the night, you didn't shut down for the season. You grabbed a blowtorch and a bar of lead, and you fixed it in the dark, with the wind howling through the gaps in the corrugated tin siding. It was a life defined by the machine's needs, a symbiotic relationship where the human provided the will and the steam provided the way. As the first light of a pale northern sun hits the gantry, you look up at the massive bull wheels, gears the size of a small house, that drive the main winch. They are coated in a thick black grease that never truly hardens, even in the depths of winter. You realize that this machine represents the peak of the steam age, a final towering achievement before the internal combustion engine changed everything. It is a monument to a time when Canada decided that no mountain was too high and no frost too deep to stop the march of progress. The buckets continue their slow climb, dripping with muddy water and carrying the promise of gold hidden within the ancient gravel. Each link in the chain is a masterpiece of metallurgy, designed to stretch just enough to prevent snapping under the sudden shock of a buried boulder. You run a gloved hand along the vibrating rail, feeling the immense power flowing from the boiler room to the bow. The machine is alive, breathing steam and exhaling the pulverized remains of the earth. You look out over the tailing pile's long, serpentine ridges of washed rock that stretch for miles behind the dredge. They are the scars of your progress, a physical record of the millions of tons of earth shifted by this mechanical beast. Every inch of that gravel has passed through the gut of the machine, scrubbed clean by water and gravity. You are not just mining, you are terraforming. The scale of the ambition is only matched by the scale of the machinery required to realize it. The transition from the raw power of the digging to the delicate physics of the processing is where the true genius of the dredge lies. As the buckets reach the top of the ladder, they invert, dumping their heavy load into a massive hopper. The sound changes from a grinding roar to a wet, cascading thunder. The journey of the gold has just begun, and you must now follow the gravel deep into the dark, humid interior of the processing decks. The internal workings are a maze of rotating steel and rushing water, a sharp contrast to the frozen stillness outside. Here, the temperature rises as the steam pipes radiate heat, creating a thick fog that clings to the ironwork. You step carefully over the spinning drive shafts, moving toward the heart of the recovery system, where the chaotic energy of the bucket line is refined into a steady, controlled flow. The earth is about to be sorted, its secrets stripped away by the relentless logic of Victorian engineering. Section 2. The Anatomy of a Metal Behemoth. The deafening crash of 2 tons of frozen gravel hitting the hopper marks the end of the Earth's journey and the beginning of the machine's true purpose. You stand on the high catwalk, feeling the steel grating shiver as the upper tumbler completes its rotation. This is the transition point where the raw, violent power of the bucket line meets the sophisticated, fluid logic of the processing plant. You are no longer just moving dirt. You are conducting a mechanical symphony of gravity and friction. The hopper is lined with replaceable manganese plates, sacrificial steel designed to be shredded so the main structure survives. In this environment, metal is a consumable resource, much like the coal in the bins or the sweat on your brow. You follow the slurry as it slides down into the throat of the trommel, a massive, rotating perforated cylinder that serves as the dredge's digestive tract. It is nearly 10 feet in diameter and 60 feet long, a tumbling cage of heavy iron that dominates the center of the deck. The engineering behind the trommel is a masterclass in scale. It must rotate slowly enough to allow the water to wash the gold free, yet fast enough to process thousands of cubic yards of material a day. You watch the giant girth gear that encircles the drum, its teeth dripping with heavy black grease that smells of burnt petroleum and ancient earth. The water is the lifeblood here, pumped from the pond by massive centrifugal units that move thousands of gallons per minute. You see the high-pressure nozzles, the monitors, blasting the interior of the rotating drum. This isn't a gentle wash. It is a hydraulic assault. The goal is to break the cement of the Yukon clay, freeing the tiny flakes of gold from the grip of the sterile rock. If the water pressure drops, the trommel sands up, a nightmare scenario where 3,000 tons of machinery grinds to a halt under its own weight. Precision engineering, in this context, means maintaining a delicate balance between the volume of solids and the velocity of the liquid. As you walk alongside the spinning drum, the noise is a physical weight against your chest. You realize that the men who worked here communicated almost entirely through hand signals and the feel of the vibration through their boots. A veteran engineer could tell if a bearing was failing just by the frequency of the hum in the floorboards. You touch a structural beam and feel the rhythmic thump-thump of the internal spray bars. It is the heartbeat of the beast. In 1915, a major dredge operator in the Klondike reported that they spent more on lubricating oil than a small city spent on its entire police force. Without that film of grease, the friction of the rotating trommel would turn the steel red hot within minutes. The oversized material, the boulders and heavy rocks that contain no gold, tumbles out the far end of the drum onto the stacker belt. You watch as a 300-pound piece of granite is tossed aside like a pebble. This waste material is carried up a long protruding boom at the stern and dumped back into the valley, creating the serpentine tailing piles you saw from the shore. It is a closed loop of destruction and reconstruction. You are literally turning the valley inside out, one bucket at a time. There is a brutal honesty to this process. Nothing is hidden and nothing is wasted. Below the trommel, the real alchemy happens. The gold-bearing fines, the sand, and small gravel fall through the perforations in the drum and into the distributor box. From here, the slurry is split into dozens of individual sluice boxes, long wooden or steel troughs lined with riffles. These riffles are the most important part of the machine's anatomy. They are simple steel bars or expanded metal meshes that create eddies in the flowing water. Because gold is 19 times heavier than water, it settles into these quiet pockets, while the lighter sand is washed away. You kneel by one of the sluices, watching the dark sand dance over the riffles. It looks chaotic, but it is a precise application of fluid dynamics. The angle of the sluice, the grade, must be perfect, too steep, and the gold is blown out the end with the waste. Too flat, and the riffles clog with sand, insulating the gold from the trap. Adjusting the grade of a 1,000-square-foot sluice table while the machine is vibrating and tilting is a task that requires the intuition of a master craftsman. You see an old-timer adjusting a wooden wedge with a mallet, his eyes fixed on the flow of the water. He isn't looking for gold. He is looking at the way the bubbles pop on the surface. The human grit required to maintain these tables is immense. Once a week, the dredge undergoes a cleanup. The machinery is throttled back, and men climb into the sluices to manually scrape the concentrated gold from the riffles. You imagine doing this in the dead of winter, with your hands submerged in ice-cold water and the wind whistling through the uninsulated walls. There are stories of miners whose skin froze to the steel plates, yet they didn't stop until the last ounce was recovered. This wasn't just a job, it was a desperate race against the changing seasons. The dredge only made money when it was digging, and every hour of downtime was a loss that could never be recovered. You notice the wear on the riffles, the way the rushing sand has polished the steel to a mirror finish. In a high-capacity dredge, the abrasive force of the slurry can eat through an inch of solid iron in a single season. The maintenance crews were constant shadows in the machine's belly, replacing wear plates and tightening bolts while the drum continued to spin. They were the ghosts in the grease, the men who ensured that the mechanical beast never missed a beat. You see a discarded wrench on a nearby bench, its handle worn smooth by decades of use. It is a silent witness to the relentless pace of industrial extraction. The engineering challenges of 1912 were solved with mass and redundancy. If a pump failed, there was a backup. If a belt snapped, there was a spare. But the most important component was always the human operator. You look up at the winch room, the glass-fronted command center perched high above the deck. From there, the dredge master controls the entire operation with a series of levers and foot pedals. He is the brain of the organism, coordinating the bucket speed, the trommel rotation, and the swing of the hull. It is a high-stakes game of sensory integration. He has to hear the boilers, feel the digging ladder, and see the tailings all at once. One specific archive-based fact lingers in your mind. During the height of the dredging era, the electrical cables supplying power to these giants were so heavy they required their own specialized railway cars just to move them into position. While this specific beast began as a steam-powered pioneer, the transition to electricity was a monumental feat of Canadian engineering. You can still see the massive copper buzzbars bolted to the ceiling, thick enough to carry the current needed to light a small town. This machine didn't just mine gold, it forced the development of the entire northern power grid. The sheer scale of the operation is humbling. You are standing inside a factory that is simultaneously a ship and a landslide. The vibration is constant, a low-frequency hum that settles into your bones and stays there long after you leave the deck. You realize that the dredge is a perfect metaphor for the era, a massive, uncompromising force that treated the wilderness as a puzzle to be solved and the earth as a resource to be harvested. There was no room for sentimentality, only the cold, hard logic of the recovery percentage. As the slurry continues to flow, you notice a subtle change in the rhythm. The pitch of the trommel has shifted, indicating a change in the geology of the bucket's bite. The machine is telling you a story about the ancient riverbed it is currently consuming. You are traveling back in time, digging through layers of gravel deposited millions of years ago. The gold you are chasing was placed here by forces of nature far greater than any steam engine, yet here you are, using Victorian physics to claw it back from the dark. The flow of water remains steady, the white water of the sluices hiding the wealth accumulating beneath the riffles. You look toward the stern, where the processed waste is being unceremoniously dumped back into the valley. The machine is leaving a trail of bones behind it, a landscape forever altered by its passage. But the belly of the beast is full, and the pressure in the boilers remains high. You prepare to move deeper into the machinery, toward the source of the power that makes this all possible. The heat from the boiler room begins to seep through the floorboards, a stark contrast to the freezing air of the Yukon night. You are moving from the mechanical processing to the thermodynamic heart of the beast. The transition is seamless. The water that washes the gold will soon be the steam that drives the pistons. Everything is connected in this closed system of iron and energy. You take one last look at the spinning trommel before descending into the humid, flickering darkness of the fire decks.